Hey guys, I'm Kiran. Basically, I do agents at RandomLabs. Technical difficulties, I guess. It says it's mirroring.
Yes.
Okay, cool. I think we're good. I think it's just like a little finicky. So anyways, I build coding agents. We've been building coding agents for forever. We built one of the first CLI coding agents like a year and like 9 months ago. And today I am going to be giving a talk on how to build a self-improving coding agent and also how you can kind of apply it to your own, like apps, agents, etc., anything that uses AI. So I'm going to get this started. I have this simple CLI using our SDK and agent under the hood, and I'm just going to ask it to diagnose the most recent failure case that we ran on our benchmark. So there's 3 things that you need to be able to do this on your tasks or whatever you want to optimize for. You need evals, you need the appropriate integrations, and you need a good agent. So in this case, the eval for us is Terminal Bench and a couple of other things that we've kind of refined internally. And then the integrations that we use are Daytona. So for sandboxing, this is super important because it lets us run a bunch of these remotely. And then BrainTrust, which is a really good observability platform. So once you have kind of insights into what your agent is doing, when it's doing it, why it's doing it, and you have isolated environments where you can repeatedly test these things, then the third thing that you need is a good agent, which is something that we have been building for a long time. So that is what this is built on. Now, this version of the agent is customized using some rule sets and some MCP servers so that it can actually accurately connect and diagnose all of kind of like the problems that it's seeing in the trajectories. So right now it's just going to go through and figure out like what went wrong. So in this task that our coding agent was working on, it was doing some data analysis thing. Honestly, it's from a benchmark. I actually don't know how to do this task myself. But it was doing some form of data analysis, and there was a problem in the code that it wrote. Now, this task requires R rather than Python for any of the data scientists in the room. And the underlying model, Sonnet, actually messed it up. It got the idiomatic format wrong. And so this kind of eval agent, which we have hooked up to BrainTrust and to Daytona and to our eval framework, is able to actually go through, and because it has access to those logs, it's able to analyze the logs and triage and figure out like what is going on here. So it's continuing to analyze the trajectory. It looked into the data set. Now it's probably going to come back to me in maybe 30 seconds with an answer about why that happened. In the meantime, any questions about what's going on?
Why'd you choose Python over vice versa?
It's part of the Terminal Bench benchmark. It's just like a pretty standard benchmark. Oh, forgot to mention. So we build coding agents similar to what you would experience with Claude Code or Cursor or whatever. The one main difference that we kind of tried to do very, very well is long context. So our agent is able to handle very complex tasks over long periods of time, and it's available in a CLI. If you just go to that link, there's free credits. You can go ahead, use it, let it rip. I'm sure it'll do well on your code bases. There's model providers, or like, I guess, inference providers that use us. There are very well-known companies that you would know the name of that use us, et cetera, et cetera. So you can go check that out. In the meantime, yeah, let's take a look at where we're at. So our analysis agent is going through, and it's still continuing to analyze the trajectory. But it did find the output from the failed tests. So then it's just going to go figure out like what was the agent thinking at that time and why did it not solve those tests when the tests were very, obvious. And once it gets back to me, yep. Okay, cool. So the root cause was this function that it was supposed to write in one way that it didn't, and it's going to go on and on like all models do. Okay, so now it's going to propose 3 potential solutions for us to work with. And And the problem with a lot of models is that they actually suggest just looking at the test code. And this is called reward hacking. You may have heard of this. This is bad. You don't want to do this for your evals. If you are making evals, do not let the agent know about the tests. Otherwise, you will not get a good eval. Anyways, so right here it's saying, oh, enhance either the testing strategy, add R guidance, or add like something specific relating to this task. For us, this kind of format allows us to iterate with our eval agent to decide on like what improvements or enhancements would be useful, if that makes sense. In this case, the most useful one is enhancing the testing strategy. So if I say, go ahead and update the testing strategy, then what it's going to do is basically modify the agent, modify itself, redeploy itself, and then go run itself on the benchmark task and see if it succeeded. And that is how you kind of build an agent that self-improves over time. Now, all this takes is a lot of different eval tasks and money and time, and you can just put more money in and you will get something better out. That's it.
Thank you.